The organization of the autonomic nervous system is primarily made up of two neuron chains. Now, we've already mentioned this before, but remember, the sympathetic system can have a neuron to a gland. So the majority are two neurons, but not all. So this two neuron chain, we have the preganglionic neuron. Now that preganglionic neuron is going to start in the brain or spinal cord. So that means it's originating in the central nervous system. This is going to be the cell body of the first neuron. So think any dendrite cell body is the main chunk of this. The axon needs to come off. And that's the preganglionic axon. The preganglionic axon is what will be leaving that initial preganglionic neuron. And it's going to be forming the synapse with the second neuron, known as the ganglionic neuron or the postganglionic neuron. So this axon is leaving the central nervous system. Because that second neuron, that ganglionic neuron, or also known as the postganglionic neuron, is located outside of the central nervous system. So we have the preganglionic neuron inside the central nervous system. The preganglionic axon is leaving the central nervous system to form a synapse with the ganglionic neuron, also known as the postganglionic neuron. From there, the postganglionic axon is going to head out towards the effector. So whatever is going to be making the change, whatever is trying to be stimulated or innervated, that's the effector. Could be any gland in the body. So we're having this two neuron chain here. So let's get back to the structural build and the differences between the autonomic nervous system's sympathetic and parasympathetic divisions. In the sympathetic division knows thoracolumbar is where we're having the origins. That means sympathetic all originates right in the thoracolumbar region. But in contrast, the parasympathetic is coming off of the brain and the sacral. That means we're coming from the brainstem and the sacral region are the origins of these preganglionic neurons. The fiber lengths are also different. In the case of the sympathetic, you're going to have very short preganglionic and long postganglionic. That means they're forming the ganglia, that synapse, close to the spinal cord. So they just leave the spinal cord and form a synapse right away. So that is the sympathetic. In the case of the parasympathetic, the preganglionic are long, okay, cover that, and the postganglionic are short. That means they leave the spinal cord or brain and head all the way out to the organs, the effectors. Then they're forming their synapse to be closer. That's where the ganglia are. So we have a couple structural differences here. And don't forget about the neurotransmitters. The sympathetic system was acetylcholine and norepinephrine. Parasympathetic wasn't. Now what we're looking at here is both the parasympathetic and sympathetic mapped out on the brain and spinal cord. You can notice that the brainstem has this origin for the parasympathetic, then down here in the sacral. But at the same time, you can see that the thoracolumbar region is where all the sympathetic are located. But look at some of the actions, what they're doing. Parasympathetic, looking at increases salivary production, decreasing heart rate, looking at bronchoconstriction, closing the airways down, looking at stimulating the gallbladder, more digestion. Remember, that's the rest and digest. But in the sympathetic, you'll notice you're seeing that it's dilating the bronchia, opening up the airways, more air coming in, increasing heart rates. You're inhibiting the gallbladder, for example. You're not really using digestion in a fight or flight situation. So both systems will innervate the same effector organs. They just have opposite responses to them. Parasympathetic to the heart slows your heart rate down. Sympathetic to the heart increases your heart rate. Parasympathetic to your lungs, your breathing slows down. Sympathetic to the lungs, that stimulation increases the respiratory rate. Parasympathetic to the gallbladder stimulates more secretion. Sympathetic to the gallbladder is going to inhibit secretions. So you have both these being innervated by the sympathetic and parasympathetic systems. But the key thing here is you should only have stimulus coming from one or the other at a time. Both the sympathetic and parasympathetic should not be innervating the same effector at the same time, because that'll pretty much cancel things out. It won't be functional. So here's your a little different view of the parasympathetic. You can see all the organs, all the innervations here. Notice cranial nerve number 10, the vagus nerve is here. We mentioned before that that's a really large nerve. Look at how much it's innervating. We're going from the heart to the lungs to almost the entire digestive system, running down into the kidney for innervations as well. And it keeps on running for even more organs beyond that. So again, that vagus nerve, a large, major nerve of the parasympathetic nervous system. But again, brainstem, sacral region. Sympathetic, you can see it's coming completely out of the thoracolumbar region, but all the same organs. So again, both sympathetic and parasympathetic innervate the same organs. The difference is, what will they stimulate that organ to do? In the case of the sympathetic and the heart, increases heart rate. But parasympathetic and heart slows the heart down. Sympathetic and gallbladder, it inhibits gallbladder secretion. But parasympathetic and gallbladder increases the secretions. So again, which one is stimulating to cause an action, or which one is trying to inhibit or slow it down? A little more about the sympathetic and the parasympathetic systems.